Good morning, everyone. My name is Deirdre Denman, and I'm the Marketing Coordinator at EandM. Thank you for attending our webinar this morning titled Voltage Monitoring Using IO-Link. After the webinar presentation, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or you can email us at webinars@eandm.com. I'd like to introduce your presenter for this morning, John Burns, Application Consultant with Siemens Industry, to get us started. Good morning, John.
Good morning. Good morning, everyone. Once again, my name's John Burns, and I am an Application Consultant for the Electrical Products Group here at Siemens. And my group focuses on kind of a pre-sale approach from a solutions approach rather than, say, product specific. And so my guys and I focus a lot on customer applications. So if you have any applications that you'd like to have some discussions with, please let the folks at EandM know, and we'd be happy to help you out. So again, to start off with, this presentation is on IO-Link, and in particular, the IO-Link monitoring relays. But I did want to go through some brief benefits and things like that around IO-Link. Again, why do customers want to use this relatively new technology? One is for sure to reduce costs for panel builders and OEMs, and also to reduce costs for end users. Another big benefit also from the end user standpoint mostly is the increased availability. It gives you that early warning sign or better fault diagnostics so that you either can prevent downtime or reduce it. And it's easily to address into your automation system from a design standpoint. You can map it directly into your regular IO addressing. And then finally, which was a big prerequisite for the IO-Link technology, was it wanted to provide easy reconfiguration. So if you're changing processes and you wanted to change some parameters on your IO-Link devices, they wanted to make that easy. And the parameters also allowed for easy replacement of failed units in the field. So any or all of these points can really drive home a really good value for your applications. A couple other key points on IO-Link. It's not a network. Technically, it's a point-to-point wiring scheme that typically will live below a field bus system or as IO off of a main rack. There's no addressing. It's the 3-wire connection between the master and the device is just 24-volt and power and a signal line. And that distance can be up to 60 feet in length. And again, the system just runs on 24-volt power. So from a product standpoint, I first want to talk about some of the master products that are available in the Siemens portfolio that are either in our PLC format, whether it's the S7-1500, the S7-1200, or the SP form factor. Excuse me. The SP form factor is what I have here on the demo that we'll be working with today. One of the latest developments in our portfolio is with this SP IO-Link Master. And we came out with a multi-function interface that now supports both Ethernet IP and Modbus TCP. And so with that new interface module, which I'm showing here with my demo, I now have opened up the world from Ethernet IP and Modbus TCP for us into the IO-Link world as well. As far as our devices go, we have quite an assortment of devices, and a lot of them are different than what you typically would see from manufacturers that support the IO-Link technology. Most of the manufacturers' solutions are for outside the cabinet, such as some kind of sensor device, photo eyes, things like that. Where Siemens primarily with the controls division focused on products that will reside inside the cabinet, but also with some outside. So from an inside standpoint, we've added the IO-Link technology to our traditional motor starters that typically is say an MSP and contactor, such as this arrangement here. And what you can do is now add a COM module on top of that contactor and have it wired in for IO-Link. We also added the IO-Link technology to our compact series line, which is basically all of those same components of the traditional all in one package. Both the traditional starters and these compact starters, you can actually group 4 starters together, and that bank of 4 starters to the IO-Link master looks like a single device. So that looks like a one device, which will greatly reduce your wiring scheme in a control cabinet for either the traditional starters, again, or the compact starters, if you do have multiple starters in your panel. Again, today we're going to focus mostly on the monitoring relays, but if you do have applications with multiple starters, let us know, and we can do another session specifically on the motor starter benefits as well. We also offer an overload relay, which I have on my panel here as well, which will be able to control and protect a motor up to 500 horsepower in size. And then the monitoring relays. We'll get, again, more deep into those functionality. But one of the big things for monitoring relays on a traditional monitoring relay, that process value that's usually on that window on the front of it is kind of trapped behind that glass. And usually the only output off of traditional monitoring relays is a single dry signaling contact. Am I above voltage, below voltage, such as? Where with the IO-Link connectivity for our monitoring relays, that process value that's behind that window, along with a whole bunch of others, are now available to be transmitted up to the automation system very easily and already scaled. And then we have a device called an RFID key switch, which we also have on the demo, which I'll talk about a little bit later on in the presentation. But that's more for access control. It's an alternative design rather than doing, say, password access on an HMI screen. You can use this device to identify who you are and what level of access or control you would have on a machine. We also have our SIRIUS Act push button line that comes in custom enclosures as well. These custom enclosures, you can design them online with our configurator, and the configurator will assign a unique part number for it, and you can order it with that part number. And when it shows up completely assembled and wired for IO-Link. And if you're an OEM, anywhere you ship that machine in the world later on, if they need another one or more of them, they can order that same part number worldwide and get it fully assembled just like the new one was. And we also offer IO-Link for connectivity right on the SIRIUS Act devices on the back of a panel as well for reduced wiring. And then lastly, we've also added the IO-Link technology to our 70 millimeter light stack product line as well. So now let's focus a little bit into the monitoring relay portfolio itself. As you can see, we have 8 different flavors of monitoring relays available that all have IO-Link technology embedded in them. From single phase or 3-phase voltage to single or 3-phase current, residual current, speed or RPM monitoring relay, power factor or active current, and lastly, temperature. So let's look into these a little bit more in detail. From a specification point of view, say for the voltage monitoring relays, again, we offer them both in 3-phase with or without a neutral contact and single phase. And they offer wide input voltage support for these. But not only do these monitoring relays have good specs as far as fitting into your application, the big reason for IO-Link is the information that you can get off of these monitoring relays. Specifically for these voltage monitoring relays via IO-Link, I can now get, say, off the single phase version, all this index 92, those are digital diagnostic bits, data bits, that can be transferred in off the monitoring relay into the automation system very easily. And from a measured value standpoint, you'll get the measured value, the process value coming in, again, already scaled into the system. On the 3-phase value or version, there's additional diagnostic bits that are also available for the 3-phase. And on the 3-phase, you get individual phases and min and max and a symmetry coming in off the three-phase monitoring relay. You also have full control over the parameterization of these relays via the PLC. If you wanted to change any of these parameterizations based on different processes, it's very easy to also change those parameters for these devices. From a current standpoint, we have both single-phase current and power factor and active current monitoring. Again, whether you're doing power factor that starts out fast and then levels off, or current that usually starts out low and then spikes up, the active current is a relationship of apparent current and power factor. So it's more of a linear curve. But all of these also transmit data back easily into the automation system as well. And in this case, for the single phase current, you can get those digital diagnostics with the index 92 representation. And with index 94, the measured values, you can also get the specific current for the single phase. Or with the other ones, you get the power factor, active current, apparent current, the voltage on the system, and the active power, all from that power factor active current. So one monitoring relay, in this case, can get you 5 analog values coming back into your process system. This one here, what I call the multi-phase current monitor, this is actually the most popular monitoring relay for our customers. And I'll show you the reason why is a couple of reasons. From a specmanship, this will either directly contact or connect to our 3RT contactors in either an S00, a 0, or an S2 frame size. So this will go all the way up to an 80 amp load and connect it either directly to the bottom of a contactor, or we have a standalone shoe adapter. So if you wanted to retrofit it into an existing application and don't want to change out your contact or any of the other equipment on your panel, but now you want some visibility into some good diagnostic and analog data, this is a great solution for retrofit applications for not only inductive motors, but for also resistive lighting or heating load applications. And again, from an information standpoint, you can see here, there's quite a bit of digital diagnostics available for this device, as well as 18 analog, different analog values that can come in off of this specific monitoring relay. Again, this one's referred to as the 3RR24 series monitoring relay. We also have the residual speed residual and speed monitoring relays as well. And again, from information coming in through IO-Link, you can get, again, quite a few digital diagnostic values, as well as the residual current in 0.1 amp or 0.1 milliamp ratings. And the speed or RPM will also give you good diagnostics and the speed coming back in, or again, already scaled into the system. From a temperature standpoint, we offer 3 different versions of temperature monitoring relays. That'll be for RTD or thermocouple type inputs for either one temperature sensor or up to 3 temperature sensors with these units. And again, quite a bit of digital diagnostics. What I'm showing here is one of the monitoring relays that only has a single temperature sensor. For the one that has 3 temperature sensors, you basically will get the first operating system functions and the temperature monitoring. And then for each of the sensors, where here it's showing only temperature sensor number 1, you'll have those same values for sensor 1, 2, and 3. And for the measured values, you'd have all that as far as the min, the max, and the average in both degrees C and degrees F for all 3 sensors as well. So a lot of people will say, why do I want to use this temperature monitoring relay? It's because it does a lot of the logic function built into the box rather than trying to offload that into the PLC system. So if you just simply want to know, hey, am I within range, or am I within the first band of range or the second band of range, this temperature monitoring system with the IO-Link technology can do all of that for you and really simplify your PLC program. So what I want to get into now is the actual demo that I have available to me here today. And again, this is a ET200SP CPU. This actually happens to be a fail-safe CPU system with a single IO-Link master card plugged into it. And the 4 IO-Link devices is one, a single-phase voltage monitoring relay. Right next to it is our overload relay, and the overload relay has a second component buried behind this contactor, which is our measuring module. And depending on what size motor you're trying to monitor and protect, that CT underneath here will grow in size. This particular one, where we have the smallest CT, it actually has a little DIN rail shoe on top of the CT. So I was able to stack the contactor right on top of it to save some panel space. The third IO-Link device, again, is this RFID key switch. And then the fourth, again, with compact starters, as a single device, I could have up to 4 of these compact starters. To save some space on this demo, I've only put 2 using, again, our 3-phase in-feed system. So a lot of times when we promote this compact starter, not only do we promote the compact starter with IO-Link to reduce your control wiring and get better diagnostics and that off of the system, but we'll also marry it with our in-feed system to save you wiring and installation time for the 3-phase bus part of it as well. Also, these are kind of like a cartridge type component. If one of these was to fail, for instance, you could easily, through the slot up here with a long screwdriver, release it, and this whole starter can pull out as if a full cartridge. So if you ever did starters like this, and you did a comb bus bar up on the top of those starters, and all of a sudden the middle starter failed, it would take you quite a while to undo all that wiring and get that starter replaced. With this compact starter design in this plug-in type of unit, you can replace failed units very, very quickly. So now let's switch from the slides into our TIA portal software, and I'll show you the actual configuration for this demo. So here we are in the portal software for that actual demo, and you can see as far as major devices, I've got my PLC here, and I've connected up this TP700 comfort panel for display purposes. If we dive into the PLC itself, you can see again, I've got my CPU and I've got a single IO-Link master. Now, when I drop this IO-Link master into this rack, just like if I dropped in any kind of other IO-Link or IO module, it would grab so much space of input and output image, process image space. So in this case, when I dropped in this IO-Link master, it starts at address 8 and goes up to address 39 for your input, and from 8 to 39 on the output. So it grabbed basically 32 bytes in, 32 bytes out of address space. So just like if you had grabbed, say, an analog card, it's just as simple. If you dragged an analog card and put it into your rack, it would also grab so much input space and output space on your rack. But just like an analog card, if you wanted to go now, say that's a 4-point card, you have to now tell the system, okay, out of those 4 ports that are available, how many are you really using? And what type of sensor are you connecting to them? Are they, say, a 0 to 10 volt sensor or a 4 to 20 milliamp sensor? It's that simple level of preparation or configuration for the IO-Link master. Again, this IO-Link master can have up to 4 devices connected to it, and the IO just comes in as digital IO. So if you need any additional IO-Link devices, you just come over here to your catalog on the side, and under communication, you see IO-Link master, and I would just add more masters to my rack, just like any other expansion card. So here with this one IO-Link master, now I want to configure it. Again, it has 4 ports available to it. Of those 4 ports, how many am I going to use, and what kind of IO-Link devices am I going to connect to it? So the way I do that is with a configuration tool called a Port Configuration Tool, or PCT. It's a free download off of the Service and Support website, and embeds itself into the portal software. So if this is grayed out that you can't do this start device tool, that means you haven't loaded that extra software called the PCT tool. But as I click on this, it'll go out and now look at my configuration for this IO-Link master. I'm actually talking to the system out there. So this is what's offline, but it can also now look online as well from a diagnostic standpoint. So the first on the top left, I'm in my master, and the tab is ports. So now the center screen is looking at information regarding the master itself. So on the port tab, I'm going to say, okay, I've got 4 ports. Here's the 4 devices that I've got configured for this master. And again, number 1 was the voltage monitoring relay. You can see it here in port 1. Port 2 was the overload relay, and that's what's here. In port 3 was the RFID key switch up here. And then the compact starter over here is in port 4. The way you load those in is on the right-hand side, similar if you're building up a rack on your PLC. You'll have a catalog, and you have different devices. It defaults with a bunch of Siemens devices, but you can also add in IODD files for other IO-Link devices. Since IO-Link is an open technology, say for instance here, I had an application with a customer that was using some Festo valves. So I went in online to the iolink.com website, found the IODD file for the particular valve pack that we were looking at for that application, and could import that IODD file. What's nice is with this system is when you bring in the IODD file, not only do you get a nice picture of the system that's coming in, but if you were to drop this in, all the parameters and all the data would be just like if you're coming in from the native company itself. So the port configuration tool is very good for bringing in third-party devices as well as the Siemens devices. So now that I have my ports assigned, if you notice on the left-hand column, if I expand from the master, I'll also have now the 4 devices on this column. When I'm highlighted up on the top, the center screen is going to focus on the master. When I click on individual devices, the center screen now is specific for that individual device. So say for the voltage monitoring relay, if I click here for parameters, these are all the different parameters that you can set up as default values for that device, so that when you download your configuration, these are the values that are going to come in. Later on with your PLC program, you can totally manipulate these parameters as well based on what process or machine you're running at the time. And again, if I click on different devices, when you click on the parameters, those parameters are specific for that particular device. On the compact starters, remember that one you have the ability to have up to 4 starters. So when you look at the parameters for when you pick compact starters, it'll tell you, okay, you have 4 starters available. How many do you really have? And you see here, starter available. I've only said yes for the first 2, and the second 2, I said no. That's how I told the system, don't look for the additional starters, is in those parameter setups. So again, that's the port configuration tool. If I come back to the master setup, and now instead of look at the port tab, if I look at addresses, now I can also look at what are the specific addresses assigned to the data, either control data coming out, say to start or stop the motor with the overload relay, or all the data coming back from, say, like the monitoring relay and the other devices. So if I click on this box here for show PLC addresses, you'll notice, remember when I said I loaded in the IO-Link master, it started at address 8. And if I click on all ports, it'll actually show me now the individual signals and the name of those signals for all of my devices. So you can see here is port 1, port 2, and as I scroll down, it'll show all 4 ports. Now, what's nice is, from a tag standpoint now, I can actually take all of this information that's in this port configuration tool and actually export it as a UDT file to be used in the portal software. So I'll show you how I do that next. So again, the PCT tool not only can be a configuration tool, but it can be an online commissioning and diagnostic tool as well. So if I close up this PCT tool and get back to the regular project, from a data standpoint, if I come into my PLC and for that UDT, what I did was I imported the UDT as an external source file. And once that file comes in, you right click on it and say, generate blocks from source. Once you do that, you then create these data types from that UDT. And say, for instance, now the data type for the voltage monitoring relay, I can come in here from my regular PLC tags, created a tag table called voltage monitor. And if I look at that tag table, I created one tag, but now it's of type of that UDT. And now if I open it up, you can see here's all the cyclic data, whether it's the diagnostic bits or the actual value of the voltage coming in to my PLC system with a tag actually assigned to it. So you don't have to worry about addressing and that. All you do is go right in to the actual tag assignment. Now what I want to get into is, now that I have it configured, if I want to go look at how this thing is operating, one of the nice things with Portal, if I have that HMI in the project, I can come up here and go into a simulation mode. And now what I'll do is I'll generate the same HMI screen in a larger fashion, easier for you to see than what's on my panel here on my demo. So you can see if I come up here for the overload relay and click on that, this 122 value is the actual voltage being displayed and being measured by this voltage monitoring relay. If I flip this switch here, it takes away that single phase voltage, and you'll see not only will the voltage go away, but I would also get the diagnostic bits telling me that it's out of range or below range as well with that system. I can also come in here and start and stop the contactor from the overload relay via this screen. The RFID key switch I talked about earlier, again, this is a new idea. Instead of using, say, passwords for an HMI, where you have a password for an operator or a password for a maintenance person or for an engineer. And the way this works is these keys, these little plastic keys, have a RFID chip embedded in the tip of it. These are read-only keys, and at the factory, each of these keys have been assigned a unique hex code combination. So if you can see here where it says inserted key, it currently says 7F all Fs. That's coming from this reader when there's no key inserted. So if I insert this yellow key, you'll see this unique hex combination is assigned specifically to this yellow key. So if you had 5 people all with yellow keys, I could assign those keys to that specific person. Or say if you had one machine operator that's going to operate multiple machines, I could give that one operator, say, 4 yellow keys. I don't care which machine he puts them in, but when he puts them in, he gets assigned that he's actually running that machine. So for instance, if that machine's running and now he needs maintenance on that machine, he can take his key out, and now a clock starts to say, hey, I'm off the clock. I'm waiting for maintenance to show up. Say the maintenance guy shows up with his key. When he comes in, you'll actually read in, if I push that in far enough, a new hex code and say, oh, not only has maintenance showed up, but now you know specifically which maintenance guy showed up. So again, it shows accessibility, but also down to an actual person level. So again, in a further presentation, we can talk about this in a lot more detail as well. And then from the compact starters, again, not only can I control the compact starters individually, but I can also get fault indication individually off of these. Now, I don't get motor current. This is just digital signal. Again, if I wanted motor current, that's where that monitoring relay, that 3RR current monitoring relay would be a better source. And a lot of times what I'll do is I'll marry that with your traditional starter, and I'll put that current monitoring relay below it. Or for retrofit applications, I'll put the current monitoring relay with this standalone shoe and be able to retrofit that right below the existing contactors with the system. So with that, that pretty much finishes up my presentation for today. I don't know if we have any questions yet that you guys have entered in. How are we doing on questions?
Hi, John. So we didn't get any questions in, but if you do have a question right now, feel free to type your question into the chat box or Q&A box, or you can email us at webinars@eandm.com. Let's see, I'll give it a little bit of time just in case we have any questions that come in. So John, one question that just came in, does this work with the 1200?
Yes, it does. Let me go back to my master slide, and you can see here's a master module that fits on the S7-1200 format. And again, this module goes to the right of the CPU. And if you're familiar with the 1200, modules to the right of the CPU are basically digital I/O cards. It's not considered a COM module that traditionally would sit on the left side. So again, if you needed more I/O link connectivity, you could easily just add more and more of these COM I/O link masters to the side of the S7-1200 CPU. I've got quite a few customers doing that now on several different applications on smaller machines. Works like a champ. Good question.
Okay.
One benefit I wanted to show with the I/O Link Master is, again, with the S7-1200 I/O Link Master, is from a replacement standpoint, is with the I/O Link Master, if you lose a device, that's easy for the master then to download the parameters for the replacement. But what happens if the master fails? With the particular SP master, the configuration does not reside on the master itself. It actually resides in the little configuration module that when you get shipped the system, usually sits on the back side of it here. So if this module was to fail, all you'd have to do is open a new one out of the box, slip it into the existing rack, and now you have your system back up and running. Any other questions?
We had a second question come in. What are the limitations? For example, how can any of the devices be configured?
How they can be configured?
What are the how many devices can be configured?
Per master, it depends on the master. On a lot of our, say, in-cabinet masters, say that for the 1200 or for the SP, those support what we call ports or devices is 4 ports or 4 devices. But again, devices are, in our work, it's mostly devices that say would give you analog feedback. But say our motor starters, our compact starters, and traditional starters, we can gang up 4 devices and make it look like one, or 4 starters and make it up to as one master. Here I can show you something to show you that 4-to-1 ratio is this slide here. So say with the S7-1200 master, again, it has 4 ports or 4 devices, but with our starters, you run the 3-wire connection to the first starter in this first COM module. And then through ribbon cables, you can actually bring in 3 additional starters. So that one 3-wire connection as a device is now actually handling 3 or 4 starters. And since that's only tying up one port, with that one master, I could actually do 16 of these starters and have individual control and individual diagnostic data coming back from the starters. So traditionally, from a full device, it's 4 devices per master. And we did that specifically because these masters are more of a slice style. So if you need more devices, you just add another one. Where out in the field, a lot of times those masters are more of a brick architecture. So for a single field bus interface, you'd have so many ports of IO link capability. But we do have a modular arrangement, which is very popular for the ET200 AL form factor. And I actually have an application utilizing that AL system, which was here. This was a customer that had a system out on a machine that required several pilot device stations, several photo eyes, and 4 Festo valves coming in on IO-Link. That's why I have that IO-Link IODD file from Festo was for this application. And the solution that I did for that was this one here. With the AL system, you have kind of a base module that's IP67 rated. And then using a kind of a little umbilical cord system, you can have expansion modules. And in this case, I did 1 expansion module for some digital inputs, and I did 3 IO-Link expansion modules, master modules, 1 to do the 4 Festo valves, and then 2 more to do these custom IO-Link push button stations. So again, it really depends on the master. If it's a slice style, it's to the limit of the digital IO of the PLC system you're playing with. If it's the IP67 format, it's usually anywhere from 4 to 8 devices. Hope that answered the question.
There was another one. There's a couple more. It was mentioned that 60 feet was the max. Mm-hmm. What can be done for longer than 60 feet? Is there a repeater?
No, because it's not a network. It is a point-to-point system. So typically, it's kind of like a cluster. It's where you have a cluster of devices, and to get to that cluster, you're going to have a field bus drop, kind of in the center of that, and then the devices will, span out, in say a 60-foot radius from that drop. That's if you had more of a conveyor where you want to really, daisy chain them down, you're going to use that field bus to kind of get them farther and then drop the master where you need the devices. That's sometimes in the IO count, that's where the better configuration may switch from an IO-Link solution to maybe an AS interface or OSI solution. If there's a particular application, I'd love to talk to the customer about it and see what are the best scenarios. We can definitely help them. More questions?
John, going back to the limitation question and how many devices can be configured, mm-hmm. What about IO-Link and SIRIUS ACT buttons and lights?
Okay. Good question. And I have a slide. So for the SIRIUS ACT buttons, let's see, there are several different what I call suitcase style modules. These suitcase modules will either snap on the back of the say SIRIUS ACT operator for being on a panel, or actually in the custom push button station right next to the operators. That suitcase module will sit inside. But say, for instance, an application here, it kind of put together where, say I've had this SP IO-Link master, again, it supports 4 ports. And if I had 4 lighted push buttons, if I hardwired those push buttons, it would take 4 wires and the IO to get the inputs, 4 more wires for the outputs, and 2 wires to get the power and ground out to those push buttons. So you're talking 10 wires. If I do this with IO Link, then I put the suitcase on one of the modules, and then going back to the SP master, I would only need 3 wires, that IO Link connection. Now, from the suitcase to the operators is your traditional wiring. On the suitcase is little connectors, and you would hardwire from the suitcase over to the push buttons, but it's a very short wiring scheme. What I'm doing is greatly reducing the long home run wires and the IO modules back at the rack. So with this one suitcase, now instead of 10 wires, I'm doing it with 3. But that suitcase is only one device. So I've got 3 more devices that I could connect to that master. So now I could do 16 of these lighted push buttons, and I could do it with only 6 wires, where traditionally that would be, I think if I did the math, it was up to 30 some odd wires that would normally have to run between IO modules and say out to your front door. So again, the devices typically will have, for the IO Link, 8 signals, and those signals can be configured as input or output. So you can any combination of 8. So you can have all 8 as outputs, all 8 as inputs, 6 and 2, 4 and 4, 3 and 5, whatever you wanted to do with it. And you could actually do that configuration in the PCT tool with the system. Let me show you that real quick. That's this slide again. So here's a picture from inside the PCT tool, and you can see it's input output 0 through input output 7. So you have the 7 bits, and you decide, are they input or are they output in nature? Hopefully that answers the question. If not, we can go further.
And then John, would this work with the Simatic S7300?
Yes, but not as an IO module in a SM300 rack. So you could put an SP rack below a 300 and then configure the SP rack below it.
Okay, and then the last question, can the ET200MP be used on a 1500 PLC rack?
Yes, that's also one of the newer additions to our master portfolio, was that we now also have a master for both the MP or the 1500 CPU, and that is an 8 port master in that form factor. So that's one of the new ones. The SP master, or the interface for Ethernet IP and Modbus TCP, opens up now the SP form factor for those other field buses. And then our other newest one is on the ET200 Eco PN. Originally, we only had 4 ports. We're now releasing one that has 8 ports of IO Link capability on the Eco PN as well. Good question. Any more?
One more came in. For SIRIUS Act is supposed to allow multiple lighted buttons with just a ribbon cable between them. Is that not supported with IO Link?
No, the ribbon cable connection for the SIRIUS Act line is a Profinet solution. So you'll have a front-end interface that will connect to Profinet as either a standard interface or a fail-safe interface. And off of that interface, you can have 20 additional operators that are connected via that ribbon cable. I would strongly suggest, if you have a Profinet system already, the SIRIUS Act with Profinet is a much better solution than the IO Link solution with SIRIUS Act. The best IO Link SIRIUS Act solution are for networks that are not Profinet, because our SIRIUS Act Profinet line is a great solution for that, and we can do a specific presentation just on that solution as well. Any more?
Okay. No, that's it. Thank you, John. That concludes our Q&A portion of the webinar. Thank you again and everyone who attended today. If you'd like to review any portion of this webinar, a recording will be available on our YouTube channel and on our website at EandM.com. We hope to have you again next Friday on June 5th for our webinar about industrial 5G. You can register for that webinar on our website at EandM.com. Thank you again, everyone, and have a great Friday.